So u equal to 0. Then accelerate to 2 meters per second squared for 6 seconds. Then the body accelerates. Its acceleration is 2 meters per second squared for a time of 6 seconds. It then maintains this velocity for 10 more seconds or 10 seconds and then decelerates uniformly to rest in 4 seconds. So it starts with the initial velocity 0, then body accelerates, okay, uniformly. And this rate of acceleration is 2 meters per second squared within a time of 6 seconds. The question here is that when the body accelerates, what will be the final velocity? Because it is starting at a point where the initial velocity is 0. So when the body is accelerating, then there should be a final velocity which is expected to be, will it be greater or less than this, the initial velocity?
Greater.
Yes. So the final velocity when the body accelerates is expected to be greater than the initial velocity. Okay. Now, what is this final velocity? So you need to determine the final velocity v. This is u1, a1, t1. Therefore, v1 will be equal to u1 plus a1 times t1. I'm using 1 because the motion is in 3 folds. When the body accelerates, start from rest and then accelerate uniformly. Then in another stage of the motion, the velocity obtained is maintained. And then in the last part of the motion, okay, the body decelerates uniformly to rest. So the motion is in 3 parts: a uniform acceleration, a 0 acceleration, and then a uniform deceleration. Please, are we okay? Are we okay?
Yes, please.
Hence the use of 1, 1, 1. So V1 will be equal to U, which is 0, plus A1, which is 2, by T1 is 6. Therefore, the final velocity when the body accelerates will be equal to 12 meters per second. Then let's come to the second aspect of the motion. It maintains the velocity it maintains this velocity for 10 seconds. So this final velocity, okay, this final velocity becomes the initial velocity for the second part of the motion. So let me put it this way. First, the first part of the motion, just to help understanding. Then when you get it, you can do it as how you want it. Then the second part of the motion. In the second part of the motion, it said the velocity is maintained for 10 seconds. So this final velocity of V1 becomes the initial velocity for the second part, which will be equal to 12 meters per second. Once it is maintained, we'll have the final velocity to also be 12 meters per second within a time t is equal to 10 seconds. Class, are we okay here?
No, please come again. Mr. Edward,
Okay.
please come again.
Listen to the second part of the motion. So it maintains, let me read the whole question, where I'm coming. A body starts from rest and accelerates to 2 meters per second squared for 6 seconds. So U is equal to 0. Acceleration is this within this time interval. Therefore, the final, when the body accelerates, the final velocity is this. I hope we are okay with this. Are we okay with the first part?
Yes, please.
Good. Then listen to the second part. It maintains this velocity for 10 seconds. Please, what does it mean? It maintains this velocity for 10 seconds.
The
I want to,
The body moves with a constant velocity for 10 seconds.
so the body moves with a constant velocity. So in the second part of the motion, the initial velocity is equal to the final velocity because the velocity is maintained, isn't it?
Yes. Yes.
So what will be this U2? What will be U2? The initial velocity of the second part.
12 meters per second.
Yes, it will
To
be
be
equal.
equal to the first part, the first
Exactly.
velocity.
That is why I'm saying that the initial velocity of the second part will be equal to, because when it accelerates to that point, the velocity there is maintained. So U2 is equal to 12, and then V2 is also equal to 12 because it's been maintained for this time or period. Are we okay?
Yes, please.
Already, your hand was up or is still up.
Yes, please. Mr. Edia, please.
Mhm.
So during the second part of the motion, there was no acceleration.
Zero acceleration.
Okay, thank you very much.
Okay. So let's look at the third part of the motion. Let's read. The third part of the motion says that, and then decelerates to rest. And then decelerates to rest. Okay. Now, what do you think will be U3?
12
What do you
meters per second squared.
Come again.
Sorry, 12 meters per second.
So U3, when it maintains this velocity for this period or time, and then from there it decelerates. So this also becomes 12 meters per second. That would be V3. What would be V3?
0 meter per second.
Go zero, because we are told and then comes to rest. Okay. What will be the time?
4 seconds.
Is it stated? Is it okay in 4 seconds? Here we can even calculate, we can determine the deceleration, the rate of deceleration, isn't it?
Yes, please.
Okay, I want you to calculate the rate of deceleration here. What is that rate of deceleration? We were given the acceleration, but over here we are not giving the deceleration. Let's quickly calculate it. If you haven't muted,
Negative 3 meters per second.
Negative 3 meter per second.
we shall see. Please, if you haven't muted, do so. Okay. All right. So when there is a need for you to speak, then you unmute. Okay. So let's look at how we can determine the deceleration. A is equal to V minus U on T. Okay.
It's
It's a deceleration, so we expect a negative. So what is the final velocity? 0, because the body has come to rest. What is the initial velocity? 12. What's the time? 4. So 0 minus 12, we have 0 minus 12 divided by 4, we have minus 3 meters per second squared. That will be the deceleration. Class, are we fine?
Yes, please.
If you have any question, quickly ask. Happy Abuatima.
Mr. Edia, so can you be asked to solve a question involving deceleration and the time becomes negative?
No, the time won't be negative. The time is not negative, is it?
No, I'm not talking in this question. Apart from this question,
I've understood where you are coming from. That earlier question, eh?
yes.
Yeah, the time won't be negative, but deceleration always the final velocity is greater than the initial, and acceleration is change in this. So the final one is the initial. So the numerator will be a negative, whereas the denominator time cannot be a negative, right? Okay, so let's move on to our question. The question demands that calculate. Okay, we have to sketch the velocity time graph for the motion. Sketch the velocity time graph for the motion. So we are plotting a graph of velocity against time. So V meter per second, T second. My velocity is initially 0, and then the maximum velocity here is 12. So the origin certainly is the 0 mark, and then meaning I have to indicate my maximum velocity. Let's assume it's here. This is 12 meters per second. So here, please, it's just a sketch. It's just a sketch. So there is no need of you creating intervals, scales. Maybe 2, 2, 2, 4, 6, 8, blah, blah, blah. No. Just initial and then the final will do. All right. It's just a sketch. Then when it comes to the time associated with the first part of the motion 6. So just something to represent the 6. Okay. The time associated with the second part of the motion is 10. And the time must be cumulative. It should add. So the next time will be 16. So 16 is here. Then the next time is 4. So 16 plus 4 would give us a time of 20. So we have 20 here. This is T slash S. Okay. Yes, we don't need to choose here. Maybe no, it's a sketch. 2 centimeters to no. This it can be done, but this is a sketch. So do it this way. All right. The motion starts from rest. So at the point where the initial velocity is 0, then accelerate. Okay, accelerate with that rate, and then that gave us during the acceleration we got a final velocity of 12 meters per second, and this took place within this time interval. So at the time of 6, it goes with a velocity of 12. So this will be the point. Then the motion, this velocity is maintained for 10 more seconds. So 10 seconds plus 6, 16. So within this period interval, speed is maintained over here. Then the motion decelerates uniformly to rest. And in a time interval of 4. So this is all that I'm going to do is to join the point. So freehand, the first velocity. Okay, where the velocity is maintained and where we have a uniform deceleration to rest. So this is the velocity time graph. This is the velocity time graph of the motion. All is well.
Yes, please.
Yes, please.
Gloria,
Mr. Data, please. So won't you indicate that 2 meters per second that the question asked on the sketch?
you don't have to indicate, but we can determine it. You see, the slope of a velocity time graph is equal to the what?
Acceleration.
The acceleration.
Good. So if you look at the first part of the motion, second part of the motion, the third part of the motion. In the first part of the motion, we have a kind of uniform acceleration. Okay. So if I find the slope of this shaded part, I have the acceleration of the body. If I find the slope of the shaded part, I need to have the acceleration of the body. Let's find it. Slope or gradient is equal to change in the vertical. So 12 minus 0 over the change in the horizontal 6 minus 0. We have on 2 per second squared. And that is exactly what the question gave us. So we must have it there, but we don't show it. Okay, when there is a need for us to calculate, we have to calculate. Please give me a second to pick this call and get back to you. Okay. Gloria.
Mr. Data, please, the question is answered.
Okay. All right. Can we move on to the second part of the question? Okay, so what's the second question?
Calculate the distance the body covers.
Good. I gave you this clue yesterday that if you have a velocity time graph, the area under a velocity, I'm coming, okay. The area under a velocity time graph is equal to the what?
The
Is equal to
distance.
the distance covered. Okay. The distance,
total distance
the total distance covered. So if we are to determine the distance at the body, all that we need to do is to find the area under the velocity time graph, and we are good to go. Two ways. The first possibility. Oh, before we move on to the distance, you see, I spoke about the acceleration. Okay, we earlier also calculated for the deceleration, which gave us -3. We can also find the slope of this part, the third part of the motion, to also find the deceleration. So A is equal to change in velocity with time. So delta V on that. What is V? What is the final velocity pertaining to the third part of the motion?
0.
0. So 0 minus, what is our U? Initial velocity. To the first
12.
interval of 4. And this will also give us the same result as we have before. So there are so many ways. Of course, here.
Mr. Edia, please, if deceleration is negative, why is acceleration not positive?
Oh, but acceleration is positive. That's what we got. Positive
No, the
12.
one you just saw.
Oh, this is a deceleration. But we are only
Okay.
when we get a positive value, it's an acceleration. When it's a negative value, then we give it a new name, deceleration or retardation.
So deceleration is negative acceleration.
Exactly. Exactly.
Yes.
All right. So total distance covered. Can I clean this side?
Yes, please.
Yes, please.
We are looking at the total distance covered. We can pick it section by section. First part of the motion. First part, what the total distance covered. And the good thing is that we can use the graph of motion or the equation of motion. And I'll take you through both so you can know when to apply any of them, right? So, you see, what shape is this? Looking at the first part of the motion, what shape is that? What shape
A
is this?
triangle. Right angle triangle.
Okay, so a triangle. So what's the formula for finding the area of a triangle?
Half base times
Half.
height.
Time.
So the distance covered can be determined using the area for determining the formula for determining area of a triangle. So half times the base. The base is 6 and the height is 12. So we have 36 meters. Okay. Second part of the motion.
Mr. Elia, please, why is it that the 36 meters is not squared?
We are using the formula to represent the distance covered. It's not an area per se.
Okay, thank you.
The formula would help us get our distance, right? So you don't have to square the meter. Distance covered. What is this shape we have during the second part of the motion?
Rectangle.
Rectangle.
Formula for finding area of rectangle is length times
Breadth.
breadth or width. Okay. And what is our length? The length is this side, the longer side, which is 12.
No.
The breadth is this side, which is
10.
10. 16 minus 6. 10. So this is equal to 120 meters. And then the third part of the motion, what area do we have there? What area do we have at the third part of the motion?
Triangle times height.
Half base times
Rectangle
height.
triangle.
Good. So distance covered here is also equal to half base. The base is 4. The height is 12. So we have 24. Therefore, let me adjust my screen a little bit. Good. Therefore, total distance covered is equal to the distance covered during the first part, second part, and then the third part. So we have 36 plus 120 plus 24. In total, this would give us
180 meters.
180 meters is the total distance covered. So simple, isn't it?
Yes, it is.
Another way. Another option. A second option. Is this. What is this whole shape we have on the board?
Looks like a trapezium.
Trapezium.
This is a trapezium, good. So we can also use the area of the trapezium to determine the distance covered. So total distance covered is equal to the area of a trapezium. And what's the formula for determining area of a trapezium?
Half A plus BH.
So half A plus B times H. Let's deduce A, B from the diagram. Okay, these are the two parallel sides. This side and this side are the two parallel sides. So side is the shortest among the two. A from this point to this point is the longest. So this is B. And then that's the part, a line drawn from the two sides, which is perpendicular to the base, becomes the height. So when I draw a line from here, any point, or any point of this side, and it's perpendicular to the base, I have the height. So this can serve as the height. This can equally serve as the height. Okay. Therefore, let's extract our data. We have how, what's the value of A? What's the value of A?
10.
That is 10. So 16 minus 6. B. What's the value of B?
20.
42. Hey,
20. The whole length from start to 20. What's the height? H. That's 12.
12.
Go. So we have, this is 30 by 6. And it's 180. The choice is yours. So what we could deduce from here is that you can choose to segregate the part into, or the whole journey into parts, find the distance covered to each one of them or each part, and we sum them up. Or if what you see can give you a definite shape whose formula, okay, can be determined or can be applied, you use that straight away. This is how to go about that when you have to use the velocity time graph. Any question? Any question? All right. Then let's look at how we can, I said we can also use the equation of motion to get the same thing, right? So let's Please, if you are writing, quickly do so. If you are done, go ahead, clean the board. Wait. That silence means that I should clean the board.
Yes, please.
Okay. So I think after going through this, when you revisit the questions I gave you, you can apply better, right?
Yes,
Yes,
please.
please.
Yes. So after today, please make time and then go back to reading the questions. As I said, you can also use the equations of motion. In the first part, u is 0, a1 is equal to 2 meter per second squared, and we got v of 12 meter per second. If I want to determine the distance covered in the first part of the motion, or during the first part of the motion, using x is equal to ut plus half at squared, I can determine it because I have everything. I've determined v. U, I think the time to that is also 6. Is it 6 seconds? Yes. Yes. Because u is 0, this part of it goes to 0. Because u is 0. So I have half at squared to use. So half by the acceleration 2 by m6 squared. So I have 36 meters for the distance covered during the first part of the motion. And that's exactly what we got, isn't it?
Yes.
Yes.
Okay, let's look at the distance during the second part of the motion. In the second part, A is 0, U is 12, V is also 12, and T is 10. No, it's a sketch. You don't have to take accurate measurement. I said this is a sketch, okay?
Yes, please.
All right. So if this are the details, A is 0, and we are looking for this. If we use S is equal to UT plus half AT squared. Because A is 0, this part, all this part goes to 0. So we have 12 by the time 10, which will be 120 meters. Please, are we okay?
Mr. Dear, please come.
You see, if we are to determine the distance covered in the second part of the motion, in the second part of the motion, don't forget the velocity obtained from here, from the first part is maintained. So u is equal to 12, v is equal to 12. Are you okay here?
Yes, please.
And the time is 10 seconds. If the velocity is constant, it means acceleration is 0, right?
Yes.
So when you use this, just as because you use t plus half at squared. Because acceleration is 0, a is 0, that part will go to 0. Because a is equal to 0.
Oh, okay. Yeah, please I get it now.
Okay. So let's look at the third part of the motion. In the third part of motion, u is equal to 12. V is equal to 0. T is equal to 4. And we determine the acceleration there. And then got as a minus 3. Please do get minus 3. 0
That's
minus
what
12 divided.
Yes,
Yes,
please.
yes, minus, yes, meter per second square. Therefore, S using S is equal to ut plus half at squared. Okay, u is 12, t is 4 plus half. Acceleration is minus 3 by a time of